Hi everyone, my name is Jamie from UC Berkeley's PEACE Tutoring, and this time I'll be talking about permutations. I'm going to kick off this topic with an example in hopes to show what permutations are, then starting with a definition. A Little League T-ball team has 10 players on it. How many ways is it possible to arrange a lineup in order? Any question that asks how many ways or how many ways can you count something is a sign of a counting problem, which will usually be either a permutation question or a combination question, and it's your job to figure out which one it is. Okay, so how many ways is it possible to arrange a lineup of players? You can imagine this. You can draw out 10 players. Each player is a distinct person. And also, the positions of the lineup are made of distinct slots. So position number 1 is not the same as position number 10. So how many ways is it possible to build a lineup of 10 players? For starters, any of the players can go into position number 1. That's 10 options, but now once you have already chosen one player to go into the first position, you have 9 players left to choose who goes into slot 2. Then keep cascading down the line until there's one person left that can go into position number 10. That's 10 possibilities for the first slot, 9 possibilities for the second slot, all the way down. Multiply everything together and your answer is 10 factorial. Alright, pretty straightforward, but how many ways is it possible to arrange a 6-player lineup out of 10 possible players? Take a second to think about how many possibilities there are. This question is very much the same thought process as the previous question. You start with 10 possible options and work your way down to the 6th position where there are only 5 players left, and then it stops there. To put that in mathematical terms, that's 10 factorial, and you divide that out by the rest of the slots that you didn't use, which is 4 factorial. And this is actually the formula for permutations. You can write this out as 10 permute 6. Permutations are just a method of counting. You can count the number of ways of arranging n distinct elements, and that is n factorial. You can also count the number of ways of arranging r elements from n distinct elements. That formula is said n permute r. The thing that you have to remember about permutations is that order matters, and this is the primary difference between permutations and combinations. It's funny that a lock like this, some people will call it a combination lock, but if you think about it, the numbers in the passcode have to be in a certain position. If that passcode was, let's say, 35, 0, and then 7, it has to be in that order. 35 can't just be anywhere. This is an example of a real-world misnomer. Okay, so that was the very basics of straightforward permutations, but circular permutations are a bit trickier to think about. How many ways can 10 distinct objects be placed in a circle? For example, let's just arbitrarily place 10 people in 10 seats around a table. You might think that the answer again would be 10 factorial. 10 options for the first seat, cascading down. But you have to think carefully here. Are the positions distinct or not? Does it matter that person A sits in this seat here? What if I rotated the circle by 1 seat? Does that count as a new arrangement or not? If we said the number of arrangements was 10 factorial, then that takes into account every arrangement, all of the people put in all of the different positions, and that includes what looks like to be random arrangements, which end up being really the same position that's rotated. As you can see, the second arrangement here is really just the first, but it's rotated by 1 seat. And since there really is no start to the circle, this arrangement is the same. As far as person A is concerned, they're still sitting with person J to the right of them and person B to the left of them. And in fact, there are 10 different rotations on this exact same arrangement that was included in the 10 factorial. The number of permutations in the seating arrangement of 10 people in the circular setting is 10 factorial, but you have to divide out by 10, which is the number of rotations or the number of seats. You can think of that as n factorial divided by n, which is really just n minus 1 factorial. All right, I have 2 challenge problems for you to try out on your own. The first challenge is how many ways can 10 distinct objects be placed in a circle if 2 objects cannot be right next to each other? This is very similar to the last problem, but I guess just imagine if 2 people absolutely despise each other, how many arrangements are possible such that those 2 people are not seated next to each other? Okay, challenge problem number 2. How many ways can 10 distinct objects be placed in a circle when neighbor seating is arbitrary? So person A here doesn't care if person J or B is sitting on the right or left, as long as A is sitting next to J and B. So give those 2 a try, and I'll go over them in the next video.